This conference will now be recorded.
I'd like to welcome you to the 7th seminar in our series on network design, utilization, application of networks for security applications. These seminars are designed to provide you with the tools to evaluate and provide the most reliable and cost-effective solutions, reducing after-sales service calls, loss of profits, and most important, unhappy customers. Today we're going to discuss troubleshooting, a term you probably think is reserved for engineers and service people. The goal of this session is twofold. First, to help those involved in the technical aspects to quickly locate and solve problems. Second is to increase the knowledge base for those involved in sales and system design. It might surprise you that while IP PoE networks are more complicated than analog, in many ways they're simpler to troubleshoot and fix. That's because where analog has many variable factors that affect operation and performance, digital is basically yes-no process. Many problems can be resolved in the design phase by providing systems that will meet the specific requirements of the installation. Once installed, problems can often be located and fixed by a process of isolating the components within the system. For today's presentation, we're going to point out troubles. We're going to point out how to spot troubles and the potential cause. And so you may want to take notes as we go through this. So the topics we're going to address today are major sources of network failures, network design considerations and troubleshooting, PoE specifications, the effects and problems, and troubleshooting your network. So let's look at the major sources of network failures. They're usually the inability to establish network connections during setup, devices dropping off and staying offline, and intermittent loss of transmission. So let's look at it in terms of network design considerations and troubleshooting. As we've said throughout this series, that basically network equipment has not been designed for the high bandwidth and PoE requirements of security applications. As such, when we apply basic what we call standard network equipment or data network equipment for security applications, problems develop. So what are those problems? Well, retry connections on startup. If a connected device is not detected, the port shuts down. Basically, that's what happens through the PoE standards. I'd like to point out that Vigitron network switches and midspans will retry the initial connection several times. While connected, if we have surge elements that we've covered in previous sessions, the ability to reconnect and apply PoE in the event a connection is lost. If a connection is lost using standard types of equipment, usually because the source of the PoE believes that a short has occurred or it's drawing more power than it should, it remains offline. Vigitron network switches and midspans will automatically attempt to reconnect without the need of a service call. The ability to monitor network connections and determine if they are valid. Well, standard network switches, midspans, etc., they don't do that. They don't know what's connected other than transmitting data and applying PoE. With Vigitron products, we have the ability of putting the specific IP address in the port, and it will continue to monitor it to assure that it's a valid connection. And then if it drops off, make an effort to reapply PoE and reconnect. The ability to provide the required PoE and account for power surges such as maglocks and door strikes. These are the highest level of surges that occur within our security application. And regardless of whether it's the highest level of all, any surges that occur could in fact shut down the port. Well, Vigitron products have the ability of monitoring it and providing that extra power. So the real key is when we look at constructing a network, and we've emphasized this over and over again, that a network is more than a single component within a network. It's more than the power source of PoE. It's more than a network switch. It's more than the wiring. Are you selling a solution that works and integrates with all aspects of the security system? Video, audio, access control, and lighting. Why network operational differences exist? Well, we've covered that. Product specifications are separate from how a product will perform in a network. Again, regardless of the specifications of the product, when it's put in a network, the performance of that product is dependent upon the network itself. So what will affect it? The types of cable and the cable distances, the amount of PoE surge power required on startup and when special functions are applied. For security networks, both individual products and product interaction with each other must be taken into account. So where do we exist on the network? Well, here's the connected device. Here's a recording or storage device. So we exist right here in the middle. So all of these elements come into play to affect the performance of a network and its reliability. What are the most often asked questions? Well, basically, I can't connect. So when we talk about connecting within a security application, let's look at the reasons for this. First of all, in basic networking, all devices that want to be communicated to on the network must be on the same subnet, must be on the same network. So key within the address, within an IP address, is that middle group of numbers. And those middle group of numbers actually dictate the subnet that it's on. And within any individual network, we could have up to 254 devices. But that subnet could be .1, .2, .3, .4, etc. throughout the line. So if I want to communicate with something with my laptop, let's say I want to set up a switch, I have to be on the same network, but I have to have a different IP address. Now, quite often the confusion exists is what about the devices that are connected to the switch? Well, they can be on a different subnet. In other words, I could have an address of where my switch is 192.168.1, and then, of course, the final 3 digits. And my cameras could be 192.168.2. But when I connect my server or when I connect my laptop in order to view it, I have to make sure that my laptop is on the appropriate subnet to view the switch. So if I view the switch, it has to be on .1. If I want to view the cameras, it has to be on .2. So in reality, though, the switch, in setting it up or viewing the GUI, could be on a completely different network than the cameras themselves. Keep in mind that what the switch is doing is just passing through its connected devices. Another problem we get into is virus protection and firewalls. We have many, many different browsers out there, and they are different, and they are different with their interaction, and they are different in their setups of their different firewalls. So quite often, if I can't reach a certain IP address, because we're dealing now with intranets, okay? Intranets, not networks that we use such as to viewing Google or other forms on a wide area type of network. So in an intranet itself, I still am dealing with software on a computer, Windows-based most likely, that is going to have firewalls or firewalls protection on it that may be running virus protection. All of these are a factor. So if I run into problems, even though it's not recommended to run this way, I may have to turn off my firewalls or disable my virus protection to see if that solves the problem, and then work with IT in order to find out the proper adjustments to get it to work. What am I really looking at, or what do I really need to look at? So to view the network switch GUI for setup and status checking, again, the network, your laptop, must be on the same subnet as an unused IP address. To view a camera GUI for setup, status, and video, your network, the laptop, must be on the same subnet as unused IP addresses that you've used to program your camera. In your network, the network switch and camera can be on different subnets. In fact, if you set it up that way, it may be an additional security factor. Just remember that to change your computer subnets depending upon the devices that you want to view. Throughout these presentations, we've divided everything up between bandwidth and power. Essentially, what we transmit, what we see, what we do, how we operate a network is divided into one of these two areas. We've spoken about how with bandwidth, the need for increased bandwidth way over what's normally in a data situation. Remember that most networking equipment was only designed to handle data files, Excel files, Word documents, etc., not large files with very high packet sizes. And in most cases, when we talk about PoE, if it even existed in the switch, it was basically the first generation of 802.3 AF, providing 15.4 watts. Today, we have megapixel cameras in the 33 megapixel range, and we have cameras that require 60 watts plus. So let's talk about the problems and about bandwidth. And we touched on these many, many times throughout the other sessions, particularly when it came to network switches. But it's worth repeating. Basically, when we talk about bandwidth and bandwidth transmission, the transmission factor, the bandwidth contained within a network, must be adequate enough to accommodate all the items that are being transmitted through, all the cameras that are being transmitted through. So what affects it? Well, we just mentioned the size of the camera itself, the megapixel quantity of it, but the picture size, again, determined by the image size, the number of frames per second, and the very, very great overlook factor, which is the packet overhead. So again, I want to emphasize this. In standard transmission, when we're dealing with our security network, regardless of the amount of bandwidth that we think we have, it's 50% less, because 50% of the total bandwidth is taken up with packet overheads. So once again, if I'm transmitting at 100 megabps, the amount of bandwidth that I have actually to transmit on that 100 megabit line is really going to be 50. If I have 1G, I'm left to 500 megabits per second. So that's what I have to deal with. And how many cameras I can transmit through that line is going to be determined by the codec, the compression ratio, and the other factors such as number of pictures per second that I want to transmit. But if I exceed that number, I'm going to lose images. Very frankly speaking, we're fortunate in this day and age in that most of the codecs we're dealing with are on the lower end of H.264 or a derivative of H.265. But if we were dealing with MPEG-4 or MJPEG, the size of the bandwidth that we require could be almost 6 times higher on that. So what about PoE? Okay, and we're going to get to that and how to read the PoE specifications. And here again, we covered that in our last session when we talked about specifications. But keep in mind that reading a power specification for a camera could be confusing. So just to review quickly, if the camera is rated by a class, we're talking about the source power of that. If a camera is rated by a particular value of a camera, such as you see here at 4.6 watts, but maximum 11 watts, that maximum is telling you it's taking into account for surges or other types of operations such as that it could be cause surges or increased power such as LED turn-ons, day-night operation, etc. So what do I program for? You always program for the maximum amount of that class. Why? Because when I do that, I'm taking into account all the factors that could lead to camera shutdowns during normal surge operations. And I don't want that camera shutting down because, as we stated, once it shuts down, it very likely will not restart again. That again, unless you're using Vigitron equipment. So when I look at a specification like that, and it shows me the class, I'm immediately going to go to the head of the class as far as power is concerned. I'm going to look at nothing else. So when I see class 3 and I know it's 802.3 AF, I'm going to make sure my source is 15.4 watts, and I'm going to make sure, regardless of how I transmit or how the methodology I use to transmit PoE, that camera is going to receive 12.95 watts. What about frames and jumbo frames? Well, we spoke about that, and we basically said in most switches, what happens is when I connect the output of a security device, which is mostly always 100 megabps, into the port of a switch, it will lock in at 100 megabps. But in almost all switches, except for Vigitron, I'm going to be limited to 1518 bytes. And above that, I'm going to get into this jumbo frame area. Well, what happens if I have a frame that's 9600 bytes and I'm trying to force it into a port of a switch at 1518 bytes? Well, depending upon the size, several things are going to happen. If it's a little bit of an offset, the picture is going to look pixelated. But as I go higher and higher in the megapixel scale of the camera, the entire picture could be scrambled. So if I have what looks like a distorted picture, it's probably a mismatch between the size of the megapixel frame that's coming into the port of the switch and the ability of the switch to handle it. That's why one of the criteria you should look at in a network switch is the ability of programming jumbo frames at the port of a switch at 100 megabps. Another problem I have is losing cameras, okay? The switch fabric situation. And this is mostly what we have as get calls on. I saw a camera at one point, it disappeared, it came back again. It may be different cameras, but everybody always assumes immediately the camera is defective. Well, it's not. It's what we call the switch fabric. And I've equated the switch fabric to a highway. We're cruising down the highway at 75 miles an hour. We're fine. We're cruising along. And all of a sudden, more cars come on the freeway. The car starts slowing down. Now I'm in a traffic jam. And the exit that I have to get off on is about a mile away, but I can't get off because I'm stuck in this traffic jam. Well, that's exactly how a security network works. A VMS system calls to the camera. It asks the camera to exit the highway, which is the switch fabric. And if it can't exit, you can't see it, you can't record it. And because traffic jams vary with time, so will traffic on the switch fabric. So what's the cure for this? Well, what we found is that the switch fabric must be at least 2 times the sum of the highest bandwidth of all the ports added. Again, 2 times the sum of the highest bandwidth of all the ports added. And that's the key development of it. You won't find this in the specification of a switch in general. And it is an important factor and it is expensive. So less expensive switches tend not to have this capability where more expensive switches do. And that's one of the reasons cameras get intermittently lost on the highway and people think it is the camera or is the switch. Another area of problems come up is SFPs, fiber. We're very fortunate that development of SFPs allows us to, in a sense, meet the needs of fiber regardless of what it is in a cost-effective manner. But here's the problem. How do I specify the fiber correctly? How do I know if it's operating correctly with the SFPs? Well, there's a couple of things to follow. Number one, the SFP must match the fiber. Basically, in a lot of our networks, we find 850 nanometer or 1310 nanometer fiber. It could be single mode or multi-mode. Some of the older fibers that we use in many analog applications are usually 850 nanometer multi-mode. Sometimes it's difficult to find out what the fiber is, but the fiber must match the SFP. The other point is the SFPs on both ends of the cable must be the same. Now, why do I say that? Because basically there's no standardization between SFPs. Well, there is one. It's called the MSA multi-source agreement, but that only covers your ability of taking the SFP and plugging it into the port of the switch. That's it. It's just the physical interchange, nothing else. So you're better off having the same SFP from the same manufacturer on both ends of the cable after you've matched it to the cable. Now, does doing all of that guarantee it's going to work? No, because the lack of specifications also applies to the lack of interchange between the SFP and the switch itself. A switch has to recognize what's being put into it, especially if it's running in the auto bandwidth mode. So you may find that even though you've done these things, there's no communication between the SFPs. And the reason is the switch cannot read the SFP, or it cannot read the bandwidth. Well, a simple check is, in most cases, you're probably running your port bandwidth on the auto mode. You may have to fix it for the appropriate bandwidth, either 100 megabps or 1G. Also, there's another quality of SFPs. Now, this is not applied to all SFPs, but it's called the DDMI, which is basically the signature that allows the SFP to communicate with the switch to read out its statuses. Again, there's no standard, no compatibility. But if your SFP does have DDMI capability, and all the ones that Vigitron sells does, and you plug it into the switch, an easy way of finding compatibility before you even start your installation is to call up the GUI of the switch and see if it will read the DDMI. If it does, it will probably work in your installation. But keep in mind, no standardization when it comes to SFPs. We focused a lot on PoE during these sessions. And basically, as we said before with PoE, when you see a specification that calls out the class, the PoE class, always go for the highest end of the class in your programming. Don't look at any other value within the structure of PoE. Don't look at the 7 watts or 11 watts or whatever. Go by the class or the highest value within that class. But we also pointed out that there's a wide range of voltages, as you can see here, in any one of these particular classes of PoE. You can see that there's a range of voltages that interact with each other. So the PSE could put out any value within that range and still be considered to be valid, but that's not necessarily the case with the PD. And the reason is because that's affected by the cable it's traveling over, the items that may be involved in the network intermittently between the PoE source and the PD, such as extenders, repeaters, etc., and the circuitry of the device itself. And what we have found is that there are cases where customers are getting the same model of camera, programming the same PoE value, and maybe 50% of the cameras wake up, work. And the reason is being new firmware has been placed in some of these cameras that requires a higher startup voltage. And the camera just doesn't wake up, or wakes up for a second or so and drops off. Because as we've also shown in our charts involving PoE, PoE is not a direct on and off process. The startup takes time and there's a ramp up, which accounts for the fact that a unit can come online suddenly during the startup process and then immediately turn off. And that has to do with the amount of power that it's requiring as it's being applied, as the voltage is being applied. Vigitron does have a small device called the VI0026, which can be placed right before the camera that can draw out the maximum amount of PoE power within the line, and in many cases overcome this condition. It cannot increase the PoE power, but it can help draw the maximum amount of power out. But as you can see, there's a great deal of variation within the systems itself. And here's that chart we were talking about that shows that the establishment of PoE, or the connect, what we might call the connect disconnect period, is actually a ramp up. And it's not just a straight line up or a yes no type of consideration. But there is a time, that's because there's a time duration where the PD, let's call it the camera, has to report back to the PSE, the port of the switch, and say, I'm here, I'm valid, I need this much power, you've given me the power that I've required, I'm okay, we're going to operate, and everything's going to be fine. So again, the PSE uses the detection pulse to make sure that the load is a valid PD with standard safety features. Otherwise, it won't turn on. If the current that flows from the PSE to the camera, PD, at the established level exceeds the level the PSE is going to shut down. That's built into the IEEE PoE standards. From the PD's perspective, if the current that flows from the PD to the connected load, such as a switching regulator in a camera circuit at the established level, and exceeds the level, the switching regulator will shut down. In other words, the camera will shut down. If the PoE voltage at the PD falls below the minimum amount that's required, the PD will not release the power, and again, the camera will shut down. We've also stressed within these seminars that PoE standards were established with CAD cabling, CAD 5, then migrated to CAD 5e, CAD 6, CAD 6a. There were never standards established for coax or single pair. But when we apply cabling other than CAD 5 cabling, they must adhere to the requirements that were established for that. There are no special or different requirements because of differences in wiring. And therefore, what you're seeing here is basically those requirements that are required for that. The amount of resistance, capacitive, and the voltage range. Keep in mind that what single pair wiring and coax share is that fact that they are just a single pair. Whereas when we talk about CAD cabling, we're getting transmission on a single pair and PoE on a single pair. So there is a distinct difference when we go to different types of cabling. The requirements don't change between the PSE supplying the power and the PD receiving the power, but the wiring has changed its characteristics substantially. One of the primary results of this is that single pair wiring or coax cabling can only handle wattages of PoE up to 36, 37 watts. That's it, nothing greater than that. Whereas CAD 5 cabling, CAD 6 cabling, etc., can use one pair, two pairs, or all four pairs to transmit PoE, and therefore can be used for values up to 90 watts. Basically, again, as cable distances increase, cable resistance increases, voltage and available power at the camera end decreases. And this is why even when we talked about things such as repeaters, as an example, what we're really repeating is more of the data element than the PoE element. And the PoE element is still subject to this idea that we're increasing the cable length and therefore increasing the resistance within the system. And that will always determine the limitation of performance. We spoke heavily when we spoke about PoE about the rush or the surge and how that can affect it, and that with any electronic device, the amount of power needed to turn on the device is much greater than the amount of power needed to maintain the device. And so when we talk about this camera operations, we have to be careful that in our planning, we're taking into account the surge element, which we estimated to be about 20%. Once again, you will not find that figure on a specification. This is the main reason why an installation will go in. The installer will install any number of IP PoE cameras that work properly, and the owner will come in during the next morning and 2, 3, 4 cameras, whatever, are offline. And that's because during the evening, we had the cameras go into day-night operation. We had LEDs turn on. We had all these processes that result in surges, and the camera asked for more power than what was capable from the PSE. So the port shut down in order to protect the system. And again, unless it was Vigitron equipment, there was no chance of it to restart. So the cameras remained offline, and in effect, reducing the effectiveness of the security system. Non-technical people very likely will assume that cameras are defective. They'll take the camera offline, they'll send it back to their dealer, the dealer will send it to the manufacturer will say nothing's wrong, they'll send it back, and you can see what goes on. When in effect, there was nothing wrong except the system wasn't specified correctly because the surge element was not taken into account when we calculated the amount of PoE power required. So maybe it's the switch. Maybe my switch isn't working. Well, did you read the specifications correctly? Do you know the actual PoE port power? Again, the actual PoE port power is not the switch total supply power. That's not the PoE budget, because the switch itself needs a certain amount of power for operation. More importantly, we need to separate the total power of the switch from the PoE budget for reliable operation. Because if we load up that switch with everything on it, run every single port to the maximum of PoE, we're creating a convection oven that could damage the switch, possibly catch it on fire in some cases, but will definitely reduce the lifespan of the switch itself. So we've come up with a formula that says if your switch just gives you one power figure, times that by 0.75, create a buffer of 25%, and then divide the number of ports into the remaining amount to determine how much power you actually have per port. So do we also know how the switch allocates power? There's no standards for that. We pointed that out in our last session. It could allocate power by assigning the highest value of PoE and the highest priority to port number 1 and reducing it as we go down the line. It could do a sharing segment to where every time we plug in a device to a port, it immediately shares all the PoE power. Or we could actually have the ability of programming it, both from priority and the amount of value. But in the first two scenarios I outlined, there's going to come out a point where you run out of PoE power, and either all cameras are going to shut down, or preceding cameras, when you get to that point, will just not operate. It's not a function or a failure of the switch. But again, there is no specifications, there is no compatibility between switches as to how PoE is actually allocated. So again, you could have any of these different areas. And in all cases, the switch will not recognize a surge. So if you're already at the maximum power of the port and it surges over that, it will simply shut down. And that's the reason my camera keeps shutting down, because I've exceeded the amount of power at the port. I programmed it correctly to the specification, but I didn't take into account that 20% surge element. We spoke about this. Why won't my cameras work? And we spoke about the differences just a little while ago of the differences in firmware or the upgrades of firmware. Well, the fact that the upgraded version now requires more power in terms of more voltage at startup, or in handling the new features that were built into it, because that's essentially what upgraded firmware does. It adds features to it, but it may not have changed the internal working. So the PoE becomes marginal. So the cameras can power up and drop off within a couple of seconds, or they can operate until those new features come into effect and then go offline and remain offline. So how do we troubleshoot networks? How do we learn about these things? How do we not jump to conclusions and immediately say, well, it's defective, I'm going to give it back to the manufacturer. Remember, you're losing all that time. Your system is down. Well, essentially, there's three important elements we can look at. One is to have a good single channel midspan PoE source to power your system. A laptop, of course, for viewing video or making sure we have connections, and a PoE meter. What can we do? Well, since we have a PoE source that we can power our unit and power the devices that are connected prior to, let's say, the camera, we can also connect our laptop. So we can look at any one of these points within the transmission system itself and isolate it by powering up the camera itself, plugging in our laptop, pinging the system, and then, since most cameras can view video based on a browser, seeing the actual video itself. We can look at the port and see what the status is. Is power on or off? Most devices within a network will have a power LED. Is PoE being applied? Is the PoE on and off? Most devices on their RJ45 connection will have some sort of indication of PoE. Do I have a link light on or off? And do I have traffic? Now, I want to say something about traffic. You will not see traffic, which is usually indicated by a flashing LED, until there's a request for traffic. But a link light should be constant, because if I'm not linked, I'm not going to see traffic. So don't think that you have to see traffic or a blinking LED until the server or your laptop has requested a connection with that device. Word on the side, Vigitron extenders do have an automatic checking system that will verify that the links between the extenders are valid. So all devices can be powered, but in order to see traffic, the NVR, VMS, or computer must request transmission. Some carriers are going offline intermittently. Well, the probable cause, again, we're going to get back to surging. Again, check out your power. Now, again, if I have a proper single channel midspan, just a single channel or a brick midspan, similar to the power supply on your computer that provides PoE power, I can go and provide the adequate PoE power at any point within the line and isolate it from the switch itself. So if I'm not seeing any PoE with the connection to the switch port, but I plug in this single channel PoE at some point and everything works fine, I know that my problem comes before that point, and everything after that point is valid and operating correctly. So again, I can go through the entire system point by point by point. So quite often, what problems do we come up with? Well, I lost a camera. I can't see a camera is the most common problem. So we go through the system, and remember, Vigitron is a transmission company, and we take our point by point by point, usually going to the switch itself. And what we say at the switch is we plug in our laptop computer and we basically ping the connected cameras. And if we can successfully ping the cameras, if we can see the video, we don't have a problem with the transmission system. The customer still has the problem, however. So where is that problem located? Well, quite frankly, what we forget is that the server that's housing the VMS system is its own network. How is that a network? Well, its input is usually 1G. If there's too much bandwidth coming into that 1G port, too many cameras, I'm probably losing a camera. But once I get past that 1G input, what am I doing? I'm internally processing the signal. That takes time and bandwidth. I'm recording it and writing it to a disk. That has its own bandwidth and time. And I'm probably not only recording it, but I'm probably viewing it also, which takes up additional bandwidth. So we often forget that the NVR or the VMS server is its own internal network. And quite often when we go through this experiment by connecting a laptop to an unused port and viewing the cameras, we often see all the cameras or can communicate with the cameras 100%. And the problem is usually isolated to that back end. Now, I want to introduce something here in terms of metering. We said that the third element was a meter. And Vigitron does have a number of PoE meters that are very unique in the fact that they're inline, they're not battery powered, so they're connected from the source to the device, so you actually get a good reading of the actual power that's there. But the VI0022 offers another unique type of checking in two areas. Number one, it's wireless as well as wired. So I can connect a laptop directly to it and view the video, ping the camera, etc. But I can also view the camera video wirelessly through Wi-Fi, which is an asset when I want to position the camera and it's inconvenient for me to be tethered by an Ethernet cable. It does have another thing that's important. Throughout the seminar series, when we've been talking about PoE, we've been emphasizing the importance of voltage. Voltage is a component of power, so it definitely affects the overall wattage, but also we kept emphasizing that the voltage has to be within the range to light up the camera. Well, if I take my 0022 meter and I just plug it in directly into the port of a switch, I can measure, without having a total connection, the amount of voltage available. So as you can see in the top area over here, if I plug it in with a, let's say, a reasonable cable, 10 feet or so, into the port of a switch, I can measure what should be the actual voltage being put out by the port. I can then take it across the transmission environment if I'm using repeaters, extenders, or if I just want to go to the end of the cable because I don't really know the distance of the cable. And I don't really know how many bends are in there or how many connections, or whether the connections are good or in good shape. I can see the difference between the source voltage and the voltage at the point where I'm going to connect it into the camera. And if there is a substantial drop, or if it's out of range, that could be where my problem is. So I could actually test out the transmission system or the cabling before I effect an installation, which may be able to allow me to spot problems and correct them before we do the actual installation. Of course, once I plug in the camera and I have a complete circuit, I can measure the wattage as well as the voltage. So 000022 is unique in several aspects. All of this, of course, is wrapped around one consideration. The better the design of my network, the less problems I'm going to have during the installation or during operation. And this is where Vigitron has its most important product. For over 9 years, Vigitron has worked with manufacturers of access control, cameras, LED lighting, wireless, not to check the performance of their products, but how they interact within a network. And this is how we also design products. So we have a huge database of all of these variable factors and how they actually work or interface within a network, because we design our products to reliably work with these products within a network environment. That's created our most valuable product, which is our design center. It's staffed by real engineers. And by now, it should be obvious that all the idiosyncrasies within a network means you can't really do this design by a computer or a drop-down menu. There's too many differences. And that's why we have real people that will work with you to design your network. And because we offer so many products, we might be able to give you 2 or 3 solutions involved. We provide the service free of charge without any obligation, regardless of the size of the network, and we ask you to please take advantage of it. The other factor is Vigitron is the only manufacturer that provides complete network solutions. These are all the categories of our IP PoE solutions, over 200 products. In fact, we're approaching 250 products now in every single category. And what does that mean to you? Well, that means to you when we give you a design, we may give you 2 or 3 or 4 different alternatives, and we'll explain the differences, but never less than reliability. Our products are designed, tested, and quality controlled in the United States with local design and service support from skilled network engineers. All this equates also to providing the longest warranty in the industry. Because we are the manufacturer of these products, we can provide a warranty that not only is production lifetime, the time a product is in production, but extends that warranty for 3 years after a product goes end of life, which means additional protection for you, your customers. So we invite you to ask for more information. We will answer your questions. We will give you design center help just by emailing support@vigitron.com. You may also contact me, Neil Heller, directly at vigitron.com. You can see my email address, nheller@vigitron.com, and my phone number. So myself or any of our staff will be happy to help you with any of your questions. We thank you again for your time and attention in viewing this video. We encourage you to view the others in these series, and we look forward to hearing from you soon.